Let us continue our discussion, and we were talking about relational model, and in this video we will be understanding how do we convert an entity relationship model into relational model. So this was the example which we discussed before of banking system, and we will be converting this ER model into relational model. Let us begin with customer as the first entity. And in the relational model, we know that we have a tabular kind of structure where we have some rows and some columns. So what we will do is for each entity, we will be creating a table where the column names will be the names of the attributes. So let us begin doing that. And we have our first entity, which is customer. And for that, let us make a table. So let us begin writing the attribute names. Let us first write customer ID, which is the primary key. So then we have date of birth, name. Let us first write the simple attributes. So we'll be writing name and date of birth. So now, if we come to age, we know that age is a derived attribute, right? So if we have something in our database which can be derived from the other attribute, there is no need of storing it. We're just unnecessarily wasting the space. So it is the convention that we do not write or we do not include derived attributes in our relational model. So we'll be ignoring this age. Now let us move ahead, and our next attribute is address. So address is a composite attribute where we have city and state as its parts. So what we do is for composite attributes, we mention its subparts in the table. So we'll not write address in the table, but we'll write city and state. So this is how we deal composite attributes. So now we're done with all other attributes except for the contacts. Now contacts is a multi-valued attribute. So one person can have multiple contacts. So if I mention contacts in the same table, what I need to do is, let's say if I mention contacts here, so what I'll need to do, I'll be mentioning ID number 1, name some XYZ, then some date of birth, some city, some state, and some contact 1 2 3, let's say. And suppose the person has 4 5 6 as its contact again. So one possible solution is I repeat the same data again here and store the other contact. This is not feasible because what happens is you're repeating the same data, and if the attributes are more, then again it's going to cost you a lot. So what we do is, instead of mentioning this contact field in this table, let us see what we do. We, for multi-valued attribute, we generally create one more table. Let us see that. So we'll be creating one more table. Here we'll be having customer ID, and here we'll be having contacts. So now what's happening here, in the previous example, we'll store, the way we'll store is we'll store all the details of customer ID 1 in this table, XYZ and whatever the details were, and then we'll be storing customer ID 1 has contact 1 2 3, and same customer ID 1 has contact 4 5 6. So this is how we accommodate multi-valued attributes in our table. So let us just quickly write about the rules which we are going to follow to uh, write this ER diagram to relational model. So the key takeaway points are, we will mention, so in case of age, we didn't include it in our table, so we'll be simply ignoring the derived attributes. Now, what about simple attributes? Simple attributes will directly go into the table as column names. Then composite attributes. For composite attributes, you have to include their subparts. So these are the takeaway points, and with the help of these, we can easily create similar tables for other attributes. So let us begin with our next attribute, which is next entity, which is employee. So let us do for employee, and similar to customer, we'll be having employee entity. And let us have a look on the attributes of this entity. So we have years of experience, years of service, which we'll directly ignore because it is a derived attribute. So we have name, employee ID, the primary key. We have joining date, and again address is an composite attribute. So let us make a table for this, and here we'll be having employee ID, the primary, then we have name, then we have joining date, and the composite attribute city and state. So this completes the employee entity. Now let us move ahead and let us see one more example. Let us go to loan. So if we try to draw a table for loan, so the two attributes which we have for this is loan number and amount, where loan number is a primary key. So this is simple, and we will be just now let us go to our next entity, which is payment. Now this here comes a special case because payment is a weak entity. So let us first write about these three attributes, which is payment number, amount, and date. So for payment we'll be having, so but uh, what is the primary key here? So if you think that payment number is the primary key, so this is not the case. Because payment is a weak entity, we need loan to describe it. So we'll also be having loan number corresponding to this payment. So one more thing which we need to store here is loan number. In other words, for weak entities, we need to store primary key of the dependent entity. So here, both of these will together act as primary key of this entity. So this was the special case which we need to pay attention. Now this happened because payment was a weak entity. Now if we move to one more entity, which is branch, this is simple. We have branch ID, name, city, and then we have two multi-valued attributes, which is assets and liabilities. So let us draw a table for branch. This is our fifth entity, which is branch. I think these are the three things we have. And we have two multi-valued attributes, liabilities and assets. So let us create one more table for assets. And we need one more table for liabilities. So one column will be of branch related multi-valued attributes. Now we discussed about the five entities, uh, and we're left with one entity, which is account. Let us discuss this in the next video in detail.